Hi, everyone. Thanks for joining us today at Vespa Now 2025 Year in Review. Now, in this session, we're excited to walk you through the major Vespa product improvements delivered this year. And these are enhancements designed to help teams build faster, more accurate, and more scalable AI search and RAG applications. Now, before we get started, I do have a few housekeeping notes. This session is being recorded, and you will get a copy of the recording and the slides within 48 hours after the end of the webinar. And we'd love to get your thoughts and questions. So you'll see a few options on your screen in the right-hand toolbar. Now, first, the chat option. You can say hi and drop in some comments. Second, you'll see a Q&A option. Drop your questions here, and we'll be addressing these throughout the session. We have a lot of information to cover today, so we want to make sure that we get all of your questions. And if we're not able to answer them at the end of the session, we'll definitely get back to you via email. Finally, you'll see a resources tab where we dropped a few links for you. Now, with that, we'll go ahead and get started. So over the past year, Vespa's engineering team has focused on three core themes: performance, retrieval quality, and operational simplicity. And today we'll share how these product updates enable you to ship production-grade AI applications with less complexity and more control. I'll start with a quick high-level overview of Vespa, and then we'll dive into the updates within each theme. Along the way, we'll highlight several spotlight updates that Thomas will dive into a little deeper. Now, we have a lot to cover, and we want to keep things digestible. So again, we'll share the links at the end, and you can explore each update more deeply at your own pace. Now, as a quick reminder for those of you who may not be as familiar with Vespa, we are the fastest and most scalable AI search platform for building enterprise-grade RAG search and recommendation systems. And this is through unifying vector, text, structured data, and ML ranking into one high-performance engine. So this really helps create the fast, trustworthy, and massively scalable AI applications. With that, let's jump into query and indexing performance. This year, we delivered major boosts to core retrieval speed. Lexical queries are now up to 3 times faster. Grouping and facet logic is much more efficient, and the new compact tensor format reduces memory footprint for vector-heavy workloads. We've also hardened ingestion with automatic binary detection, so schemas don't interrupt indexing. This is at a high level, some of those key features that we've improved with query and indexing performance. I'll go ahead and quickly walk through some of these. And as you can see, Thomas, he'll highlight those spotlight items for us. Now, for automatic instance migration with Vespa Cloud, we know that cloud providers like AWS, Azure, and GCP are constantly rolling out faster and more efficient instance types. So starting with June 2025, Vespa Cloud automatically moves your nodes to these newer generations as they become available. So this is really no action needed from your team, and you get better performance with no downtime. So again, if you're on Vespa Cloud, you'll have started seeing these automatic rollouts. And if you're not on Vespa Cloud yet, this is something to take into consideration where you do get that better performance with no downtime. We've added binary data detection in string fields. So this really is about ensuring that, if you get those messy or corrupted data into your Gen AI pipelines, we can automatically detect and reject that. So this really helps keep your application stable, secure, and reliable. We also added rank score drop limit for more efficient global ranking. And if you're familiar with this capability, Vespa's rank score drop limit lets the system discard candidate hits whose scores fall below a certain threshold. So these are those items that can't possibly make it into the final top K results. Now, before, this limit only applied at the node local ranking stage. But after this update, the drop limit also applies during the global ranking phase. Now, we've also added geo-bounding box filtering. So with this update, you can now filter search results to a specific rectangle on a map using the new geo-bounding box operator. Now, this is an easy way to limit results to an exact area like a neighborhood or delivery zone. It works alongside Vespa's existing point and radius geofilters and plugs directly into your ranking pipeline, so you get precise geographic filtering without that extra complexity. And then facet and predicate filtering inside grouping. We've made grouping much more powerful. You can now add filters directly inside your grouping expression using simple logic, as well as range filters. So that means you can run analytics and apply exclusions all at once without extra queries or post processing. So, for example, you can group purchases by customer while filtering out certain sales reps or ignoring prices within a specific range in the same query. We've also added better control for time based analytics. So you can now, for example, set the time zone when using time functions. So metrics like purchase by hour reflect your actual business hours. So that's a high level on those first few items. Now, I want to bring Thomas in, who is a senior engineer at Vespa, to dig in a little bit deeper about our faster lexical search queries and our HNSW improvements. Thomas?
Yeah, thank you, Bunny. So lexical search is a cornerstone for most of our customers' applications. And at the core of lexical search is our weak and query operator. Weak and is designed for a less strict and matching with improved performance. It allows you to combine multiple conditions and terms across different fields, retrieving documents that may not match all terms, but at least some of them. And although weekend is very efficient by itself, it may retrieve or match many documents, especially given a lot of common terms for the query. And since all the matched documents will be exposed to our first phase ranking stage, sometimes it might make sense to not use or filter out which terms are used so that the queries do not get slower than acceptable. So to mitigate this, we have added some new configuration parameters that allow you to control this in more detail. The first one of these new parameters is the stop word limit. As an example, if you set the value for this to 0.6, this will drop all query terms that occur in at least 60% of the documents. The reasoning behind is that these do not bring much value to the query. The second one is the adjust target. This works on documents. And as an example, if you set this to 0.01, this excludes the documents that only have terms that occur in more than approximately 1% of the document corpus. The actual threshold is query specific and based on the query term score whose document frequency is closest to 1%. And the third one is the filter threshold. This allows you to use more compact posting lists for common terms. So if you set the filter threshold to 0.05, this ensures that all terms that are estimated to occur in more than 5% of the documents are handled with compact posting lists represented as bit vectors instead of the full posting lists. This makes matching a lot faster at the cost of producing less information for BM25 ranking, as only a Boolean signal is available. And last, we also added the option to allow drop all. The default behavior of the weekend operator is to always keep at least one term, even though all are considered stop words. This is to avoid returning no hits. But if combining with a semantic search in the hybrid search setting, it may often be desirable to actually drop all weekend terms and rather to rely purely on the semantic matches for these cases. If you set the allow drop all, this will be enabled. Yeah. And if we move on to the HNSW improvements, we also have a lot of goodies for you here. So Vespa has supported approximate nearest neighbor search with HNSW or hierarchical navigable small worlds algorithm for more than 5 years. This year, we added a significant improvement to our HNSW implementation. The issue that we sought to resolve were for queries that combine HNSW search with a filter, such as, for example, filtering on a product price range or a category, if you're talking about an e-commerce product search. Before this recent improvement, these queries were processed as follows. While you're performing an HNSW search, if a document with a low distance to the query is found, you check whether it passes the filter, and if it does, add it to the candidate queue. And this works well if most of the documents pass the filter. But in some cases, if the filter is very restrictive, a large part of the HNSW graph is traversed and a lot of vector distances are computed. Mostly of them are for documents that do not even pass the filter. This can be observed in the plot to the right, where you can see that the response time spikes when the filter gets very restrictive. The solution is implementing an algorithm which is inspired by the Acorn paper published last year. And the approach is that instead of computing the distance for all neighbors of a node to the query, and then checking which of the relevant neighbors pass the filter, like we did before, we take the neighbors and the 2 hop neighbors of the node, and for those that pass the filter, then computes their distance to the query vector to see if they're relevant. So the threshold for which or when this should apply is controlled by the new filter first threshold parameter. And you might note, or you should note, that for some hit ratios, which is the strength of the filter, this might produce a dip in recall. This can be mitigated by checking the 3 hop neighbors of a candidate node. But this again can get very costly for some nodes. If you multiply 2 by 16 raised to the power of 3, you get 32,768 candidates to be explored. Thus, we want to only check the 3 hop neighbors for nodes where the neighborhood is not too large. How this is done is controlled by the filter first exploration parameter. And this actually allows one to finally control the trade-off between response time and recall for approximate nearest neighbor search with filters. All of these parameters can also be passed query time for easier experimentation. Yes, that wraps up the HNSW improvements, and you can move on to the next slide, Bonnie.
Great, thanks, Thomas. Now, another huge theme for 2025 was better retrieval and ranking for LLM-based applications. We added integrated chunking, chunk-level scoring, layered ranking, and full transparency in the global phase. And these make RAG pipelines significantly more accurate and easier to reason about. I'll go ahead and start with the first one, which is global phase relevance score. Now, when Vespa ranks results, it gives each document a score that reflects how relevant it is. And that score is created early in the ranking process. With the latest update, that relevance score is now also available at the final stage, where Vespa combines results from all nodes and decides the final order. We also added support for several newer high-quality modern BERT embedding models. Now, these models generate richer, more accurate vector representations of text, which directly improves semantic search, RAG, and recommendation quality. Now, on Vespa Cloud, using these models is simple. You just reference them in your services XML file, and Vespa takes care of hosting, scaling, and serving the models for inference. We also created compact tensor representation. Now, as you know, sparse and dense vectors are commonly mixed and used for embeddings and semantic features. These tensors can become large, and the traditional JSON format adds significant overhead. But with our latest update, you can start using a compact text representation that dramatically reduces serialized size and eliminates float by float JSON parsing. The result is faster ingestion, lower latency, better efficiency, and improved overall performance. Now I'll hand it over to Thomas to dig in deeper about layered ranking.
Thank you. Layered ranking is a really interesting concept, which is quite valuable to several of our customers. Now I'll try to explain why. So if prompt engineering was the new word of 2024, context engineering has become even more important in 2025. This term is used to illustrate the process of engineering the right context in form of tokens or representations of words, which will make the LLMs more efficient at fulfilling their task. It has been shown in research that LLMs perform significantly worse if they are provided with irrelevant context. In addition, LLM inference is commonly priced per token, and the inference time increases quadratically with the number of tokens it gets in the input. This is why it's so important to provide the relevant documents and information when retrieving documents to pass through to an LLM. Additionally, when embedding documents for semantic search, chunking has become a common approach to limit the amount of information to embed at once. As if you embed too long texts, it will make it harder to capture the inherent information and thus to retrieve the relevant text. When chunking documents, you are forced to choose one of two approaches when you're modeling and indexing your documents. Option 1 is to index at the chunk level. But this again will force you to duplicate all the relevant document metadata that may also influence the relevance of this chunk. The option 2 is to index at the document level, with the chunks as an array field of the document. But this has the significant drawback that you only rank at document level. Then you will need to return all the chunks of the document to an LLM, even though maybe only a single or a few chunks of that document is actually relevant. Vespa has now figured out a way to get you the best of both worlds. And personally, I think this is a really underappreciated feature that deserve even more recognition. Maybe it will as more people will use it. But certainly our customers doing RAG at web scale already use and praises it. So the approach enabled by Vespa is to choose the index documents with chunks as an array field of the document. This solves the duplicate metadata issue. And then, in order to solve the issue of returning all the chunks to the LLM, we have introduced a way to specify how the elements to be selected and returned should be chosen. And the cool thing about this is that this can be a summary feature as calculated by a rank expression, allowing our customers to use both lexical scores, semantic scores, or any other chunk level attributes and combine these through a tensor expression however they like. This is incredibly powerful, and I think many have yet to discover this. But those that do are sure to have a real edge, as I have not seen any other vector DB or search engine providing a real solution to this problem. Thank you,
Amazing.
Bonnie.
Yeah, great. Yeah, it sounds very flexible and very powerful. Thanks, Thomas. Now, we also invested heavily in developer productivity. We have a new Python query builder, PyVespa relevance and match evaluators, and summary features inheritance. Now, these accelerate experimentation and reduce time to market. And I'll explain more at a high level, starting with the new query builder. So with this new query builder, Python developers can now also generate YQL, and this makes it easier to create valid Vespa queries in code. We also have the Vespa Match Evaluator, which is a helper tool in PyVespa that lets you measure how well your search configuration is matching the documents it should match. With the summary features inheritance update, when you inherit from multiple rank profiles, Vespa now also carries over their summary features, which gives you more flexibility and consistency in building complex ranking strategies without redundant definition. So before this update, if you created a combined rank profile, Vespa didn't inherit the summary features from both parents. You had to redeclare them manually. But now you can simply inherit, and Vespa will automatically include all of those summary features from both parents. With the CLI multi-get update, you can get a list of documents. And this update was actually submitted by one of our customers. So again, we'd love to hear your feedback. Feel free to join our Slack community, contribute, your feature requests, things that you'd like to see in the product, and they can end up on the latest product update. Now, getting data into and out of systems is often time-consuming and challenging, but with the Vespa's log stash plugins, this is much easier. So this can be, importing data from a CSV file, Postgres, Elasticsearch, self-hosted to Vespa Cloud. We do have a blog post about this, but this makes things much easier for getting data in and out. And I'll hand it over to Thomas to talk about the RAG blueprint.
Yeah. So the reason why we made this RAG blueprint was that we had worked with many customers which were doing RAG, and there was a theme that we noticed of common challenges that they were facing and questions that they were asking. Some of the challenges were overcome by advising them on how to use existing Vespa features. And for some of these, we also had to develop new features, such as, for instance, the element-wise BM25 ranking feature, built-in chunking, and the layer ranking framework that I talked about earlier. So John, our CEO, he first gathered a series of recommendations into a slide deck, but we also wanted to have a practical reference implementation of an application that showed how this could be combined. And this was the reason why the RAG blueprint was born. During development, we noticed that some generic evaluation tooling that would be very valuable to our users. So we added the Vespa Evaluator and Match Evaluator, which was mentioned here, to our Python SDK. These classes make it easier to do quality evaluation of a Vespa application across a variety of common information retrieval metrics. So all you need to do this is a set of queries as well as labels for the relevant document IDs for each query. In addition, we often encourage to make use of Vespa's unique phased ranking framework. The RAG blueprint implements this. We have a cheap first phase ranking, which is a learned linear combination of semantic and lexical features. For the second phase, we show how one can use the learning to rank approach to train a gradient boosted decision tree model for ranking, which is still the go-to approach for those doing learning to rank at scale due to its efficiency and good quality. And last but not least, the RAG blueprint exemplifies how one can use a tensor expression to choose which of the chunks that should be returned for the top ranking documents, while still taking into account document level metadata, such as recency or popularity for document ranking. The RAG blueprint has since become a resource we often reference, and we firmly believe that the understanding the contents of this is a great resource for anyone looking to build quality RAG applications at scale.
Great. Yeah, and this RAG blueprint I think is really cool because this is something that we also developed alongside some of our customers like Perplexity to really ensure that we have the best practice for a high quality scalable RAG system. And we'll provide the resources for this as well. We have the blueprint that walks you step by step through the process of building. We have a video that kind of gives you the high level overview. And then we have those kind of key best practices that Thomas mentioned as a separate asset if you're not ready to build and you just want to kind of see what those best practices are. So lots of good resources on this. Very excited about this RAG blueprint. Now that covers at a high level the feature updates for 2025. Now we did move quickly today so that we could cover everything. Now, if you want to learn more, you can get updates about the latest changes to Vespa events or things that we hope you find useful in the Vespa newsletter. The links are provided here. We can also drop them in the resources button on the right-hand side. And also feel free to join our Slack community. And if you are a Vespa user, we invite you to share your experience on G2. We won't be collecting your data or sharing your information. This is really just to leave a quick rating, tell others how Vespa's helped improve your search or AI workflows. We'd love to hear your story.